David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. Today's lesson covers how to take integrals with composite functions. And if you remember when we did our chapter on derivation, the main tool we had for that was the chain rule. And so we could use the chain rule to take the derivative of something like 4x minus 5 to the 6th power, and that would give us the derivative. Now we're taking something that is a composite function, but we're going the other way. We're integrating that. Now, of course, from the previous lessons we've done in this chapter, you know that you could just expand this binomial, perhaps use the binomial expansion pattern and just get your binomial expansion with all the terms, and then you could integrate. But binomially expanding this is actually quite a bit of work. So what we're going to do is I'm going to give you a rule for how to do kind of like the reverse chain rule, sort of, and then you could do these with a lot fewer steps than that. Okay, so what I've done here is I've spelled out this rule for this composite function, like the integration rule for that. And you'll notice that it looks kind of similar to the power rule in the same way that the chain rule looks a little bit similar to the power rule. So check this out. If I'm taking the derivative of ax plus b to the n power, if I take the integral of ax plus b to the n power, what I'm going to do is I'm going to do 1 over a times n plus 1, that's the power, here's the a, the coefficient on x, times ax plus b, that's just our function inside, to the n plus 1, and then of course plus c at the end. So now you can do a plug-in step on this one. So what I'd like you to do is be bold, pause the video, and just take this problem, this integration, use this pattern, and do your plug-in step right there. Okay, so here's how I did that. I noticed, okay, so my a is 4, there's the a. My b is my minus 5, that's here. That would go here. And then my n is my power on my binomial there. That's my n. So my plug-in step is going to look like this. 1 over a times 6 plus 1, which is 4 times 6 plus 1, times my binomial, now raised to the 6 plus 1, power. So finishing that up, you're going to get 1 over 28 times 4x minus 5 to the 7th power. And that is our integration of that binomial with plus c. Whew. Okay, so to keep up on our derivation skills and to verify that we did this correctly, what we need to do now is just check. Let's take the derivative of our integral, and that should wind us back here. So I've set you up on that. That's d dx of 1 over 28 times 4x minus 5 to the 7th power. So go ahead, pause the video, and take that derivative. Okay, so here we go. Remember our chain rule. You take the derivative of the outside times the derivative of the inside. So the outside is reducing the power by 1 and multiplying the old power in the front. So that's just our power rule applied on the whole thing, leaving this alone. So we brought our 7 down, we put it here, we have our 1/28 already in place, and then we reduce the power by 1 and we leave the inside the way it was. Then we multiply this by the derivative of the inside, and the derivative of 4x minus 5 is just 4. Now you can see that this one is going to reduce on down because I have 7 times 4 is 28 divided by 28, so that makes all of this stuff go away, and basically all we have now is 4x minus 5 to the 6th power. Woohoo! That worked! We wound up back where we started. So we integrated this expression, followed it on through, and then we took our result and we did the derivative of that, and we wound up back where we started. Okay, so I'd like to give you 2 more laws, so we have a total of 3, or rules, or laws, or theorems, whatever you want to call them, that will help us work on taking integrals of composite functions. So here's what we just did. Okay, so I won't explain that again, but it's just written up here for notes because we're going to do a bunch of examples right there. Then here's the one when you're doing a 1 over your composite function. Remember, this is the form of that composite function here. So we have 1 over ax plus b dx. That's going to be 1 over a times the natural log of the absolute value of ax plus b, and of course r plus c. So that looks really similar to the last rule we got. And then this one also is going to look similar. If we're taking the integral of e to the ax plus b, then dx, then what we're going to get with that one is 1 over a times e to the ax plus b plus c. So 3 new rules, although fairly similar to things you've seen before. Okay, so let's do a problem. Okay, let's try this one. Here we go. We've got 1 over 3x plus 2 dx. So figure out which one of our rules applies to this problem, and then go ahead and perform the steps. This one does not require a lot of steps. It's pretty straightforward. So go ahead and do that and come right back. All right, so here you go. My a is 3 from I'm using this second rule here. This is when we have a fraction where we've got a power of 1 on the bottom. And so what we do is we take our a and we put it out here. So that's my 1 over 3 for this form times the natural log of the absolute value of my ax plus b, which is 3x plus 2. So my absolute value of 3x plus 2 plus c. So there is my integral. All right, now give this one a try. And I'll give you a pointer. Obviously, the rule that you're going to need to use at some point on this one is here, where we have e as our base. This is, again, a natural log, or with the number e. But there's a little bit more going on there. So go ahead, pause the video, see what you can do. Okay, let's see how you did. So check this out. My 2 is a constant times my function. So I'm going to simplify first by pulling the 2 out of the integral sign and putting it right there. Now I can take my integral of e to the 5x minus 1. It's a direct application of that rule. And what I get is 1/5 times e to the 5x minus 1. That's this 1 over a. A is my number, my coefficient of x, which again is my coefficient of x is right there. So I have 1/5 e to the 5x minus 1. I have 2 times 1/5, so that gives me 2/5 e to the 5x minus 1 plus c. Okay, let's do one more. We're just increasing the difficulty level a little bit. So why don't you take a look at that one? You have 1 over 5x plus 2 to the 4th power dx. So go ahead and see what you can do with that. Take the integral for that expression. Okay, a few more steps to this one. Let's unpack this. So the first one is, since I have a power here that's not just 1, I can bring it up and I can do 5x plus 2 to the minus 4 instead of 1 over 5x 2 to the 4. So that opens this up, and now I can just apply my straightforward composite function integration rule right there. So what I'm going to do is I'm going to take my 1 over a times n plus 1 times the original function in here, the inside function, raised to the n plus 1 power. And so simplifying on down, this becomes 1 over 15, negative 1/15 times 5x plus 2 to the negative 3. Now, I could simplify this on down quite a bit by putting 1 on the top, that would be a positive 3, bringing that whole binomial to the 3rd power down here, putting my 15. And then, of course, there is my constant. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.